Today we're going to talk about some laws of logarithms, and so let's start with that, laws of logarithms. And so the first one is going to be log base A of A times B is equal to log base A of A plus log base A of B. So whenever you see that you have multiplication in here, you expand using addition. The second one is log base A of A divided by B equals log base A of A minus log base A of B. And so whenever you have this division here, you expand using subtraction. And then the third one is log base A of A to the C power equals C times log base A of A. And so whenever you have this exponent up here, you move it to the front to make it multiply by your logarithm. And then one important formula to make sure that you know is change of base formula. And change of base formula says log base A of B equals log of B divided by log of A. And so I remember that because the B is higher up than the A right here. The B is higher than the A, so the B goes above the A. And now some examples using these laws. And so the first example we're going to do is going to be expanding logarithms. And so I'm going to give you the logarithm, the natural log of A times B divided by the cubed root of C. And so the first step we want to do is we want to take care of the division. And so we're going to separate that using the second rule up here with division, which we separate using subtraction. So we're going to end up with the natural log of A times B minus the natural log of the cubed root of C. The next step here is going to be rewrite our radical. And so we're going to leave the first one as the natural log of A times B minus the natural log of this cubed root of C right here. If you remember from your properties of exponents, a cubed root or radical can be written as a fraction exponent. So it's going to be C to the 1/3 power. And now we're going to expand this first term with the multiplication. And so that's going to get us to rewrite this as the natural log of A plus the natural log of B, and then minus that last piece that we didn't touch. And so we did that using the first property up here, where when you have multiplication, you expand using addition. And then our final step is to take care of the power, or the exponent. And so right here we have this exponent, and according to our last law up here, you move the exponent to the front of the logarithm. And so this is going to become the natural log of A plus the natural log of B minus 1/3 the natural log of c. And this is our final answer. Now the next example we're going to do is going to be going backwards, and we're going to condense the logarithm. And so if I give you 3 log of x plus 1/2 log of x plus 1, we want to condense this into one single logarithm. And so the first thing we're going to do is we're going to deal with the exponents. And now you're probably saying there's no exponents in this problem, but if we look back up here, the law including exponents, and when you expand, so when you go from left to right, puts the exponent in front of the logarithm. And so if we look down here, we have numbers in front of our logarithms, which means that we want to take these and we want to move them up to become our exponents. And so we're going to get log of x cubed plus log of x plus 1 to the 1/2. Alright, so now this 1/2 right here, we are going to rewrite that in radical form. So we're going to rewrite the fraction exponent. And so remember that fraction exponents turn into radicals. So it's going to become log of x cubed plus log of the square root of x plus 1. So now, if you notice, right here we have addition. And according to our first law, when you have addition, it's becoming from multiplication. So we need to take this and we're going to multiply our two arguments together inside of a single logarithm. So the third step here, we're going to deal with the multiplication. And so this is going to become log of x cubed times the square root of x plus 1. And this right here is our final answer. And now I have one last example. It's a little bit more complicated of expanding, so it's going to be an expanding example. And so if we have log of z over the square root of y times x cubed. And so the first thing we want to do here is deal with the division. And so division tells us we separate using subtraction. So that's going to give us log of z minus log of our denominator. And now we're going to expand dealing with our multiplication right here. And so that's going to give us log of z minus, and now since the multiplication is inside the logarithm being subtracted, you're going to put all of this in parentheses. So it's going to be log of the square root of y plus log of x cubed. And now we're going to take this radical and we're going to rewrite that as an exponent. And so we get log of z minus the quantity, log of y to the 1/2 plus log of x cubed. And so now we're going to deal with the exponents. So this exponent and this exponent. And we're going to move those exponents to the front of our logarithms. And so that's going to give us log of z minus the quantity 1/2 log of y plus 3 log of x. And then you can stop there and have that be your final answer. Or you could use distributive property with this minus sign in front and multiply it by each term inside of the parentheses. And your final answer could also be log of z minus 1/2 log of y minus 3 log of x.